Hey YouTube fam, welcome back to another episode of Code with Annie. Thank you so much for all the support you have been giving me. And with all the support, I have delved into another playlist now, which is basically programming with Java. So this is going to be a new playlist of videos which will focus on writing code with Java as the main programming language. And for this series, we'll be understanding what Java is all about, its current significance in the market, and also about the different frameworks with which Java is usually used. And we're going to see everything about Java from where it was born till where it is used now. And through this series of videos, I'm going to be illustrating with several programming examples, live code examples as well, to show you the different functionalities that are available within Java, how we can leverage it. This includes both object-oriented functionalities as well as the newer functional capabilities that are built into Java as we go with newer updated versions of Java. And this video will be mainly focusing this video in the sense this current video that I'm recording now is going to focus on the history or the place from where Java was born and how it has grown and where it stands today. So this is just going to be an overview session and a small demo of how Java compiles into classes and how the classes are executed further. So let's delve in. So Java basically is a language that was built in 1995, developed in 1995 basically by James Gosling, and it was used for mainly TV remotes and set-top boxes. As weird as it sounds, but this was the purpose of this language when it was released. That is the very first draft of Java. It was not even called Java at that time. It was called as Green Talk. And all the files, the programming files were named with extension .gt. This got later renamed to Oak. And then finally, it was decided that let's call it Java. And all the files were with extension .java. There's also a coffee symbol with um, whenever you see the logo of Java, right? There's a coffee symbol because Java basically was an aromatic coffee flavor. So there is that as well. But as we look at the history, it started off in 1995. It's more than 28 years old. And this language got significant updates over a period of time. The most demarking difference between Java and already existing OOP languages like C++ was, let's say, there was a lot of flexibility that Java provided and convenience. Those two factors made it slowly become a more preferred language as opposed to C++. One example is memory management. So memory management was done in C++ and C. I think both of these required the user to allocate the memory, allocate and deallocate memory by user. Java basically removed that concept. Basically, in Java, you don't have the concept of pointers that you have in C and C++. You do have pointers, but that is handled internally by Java itself. So it doesn't give you any access to how the memory is allocated for objects because that is taken care by a garbage collector. So any excessive memory being used by objects is taken care by the garbage collector. It will take it and it will have its own heap space. It will handle the memory. Garbage collection in itself is a different topic, which I'll be talking about in another video as to how it handles the life cycle of objects in Java. But yeah, so basically this solved one headache for people because they're not getting out of memory errors due to coding. Obviously, you do have out of memory errors in Java as well, but they may not be something that you will have to handle by properly allocating and deallocating memory. It should be mostly handled by garbage collector unless you have a lot of objects defined randomly in your code and you're not your garbage collector is even not able to handle it, you might get an OOP, out of memory, sorry, OOM. Okay, so that solved a significant problem. And apart from that, there were other things also that came into Java that made it a better language as a whole. And this was gaining a lot of traction by late 2000. What happened next is Java became integrated with several frameworks such as Spring and Spring Boot, which came after Spring. Also, when Android came into existence, basically the Android mobiles came into existence, their backend was written in Java. So we had Android Java, right? There are different flavors of Java that came into existence. And along with this, Java until that point was completely focused on object-oriented style. And post Java 8, certain functional programming aspects also came into Java. So you can see that the history of Java, it started off for a very small purpose and it now almost dominates the market space with its backend frameworks. And many companies still use Java and because they believe it's quite reliable as a language. And you find several Java developers out there. And yeah, this is one of the primary reasons why Java is quite a popular language now. Apart from this, if you want to look at other languages like Python, JavaScript, Golang, which are also gaining traction these days, Java still holds its place in the market for two reasons. One is many companies have adopted to Java and their applications, sorry, are quite old. So when Java came out, it's a certain applications, certain companies you find they were built with Java JDK versions 1.6, they updated to 1.8, and many are still even using 1.8. So they don't want to move out of Java because they find this to be working perfectly fine. So they just keep using it. And second important point is plethora of Java developers out there. So you find a lot of people who know Java, and Java is introduced as a curriculum in engineering subjects as well in India. So you will find almost every grad out of college who has an idea on Java. So there is that as well. Now, what exactly does Java contain? Basically, Java is nothing but a combination of JDK, JVM, and JRE. I'll explain what these are. So JDK basically is Java Development Kit. Okay. This contains, JDK contains JVM, which is Java Virtual Machine, and JRE, which is Java Runtime Environment. Okay. Now, what is JVM, JRE, and JDK? So JDK is basically the bundling, or this is actually the combination of all the classes, inbuilt classes of Java, everything, the libraries, the external libraries of within Java, external libraries instance, all the Java specific libraries that make you use when you write a Java class, these libraries will help you. These are inbuilt libraries which will help you provide a lot of inbuilt functions. And those are all within the JDK. And JVM is the environment where your Java code will be executed. JRE is the Java runtime environment where your code is executed. JVM is the one which will execute your code in JRE. So JDK has all the inbuilt functions in Java. JVM helps you execute a Java code, and JRE provides the environment where the code can be executed. So put it simply, one provides all the inbuilt functions for you to leverage when you write your code. One helps you to execute that code, and one gives you the environment where this code can be executed. So all these work in tandem and provide you what you need. So let me illustrate this with the help of an example in IntelliJ. So you see this code with me module, right? So if you go here in Java, you see all these classes. So these are all the Java classes that we had. This is how the class looks like. I'll explain in detail about everything, but these are the classes. So when I say build, in this is a Gradle projects, I have already shared with you how we can set up a Gradle Java Gradle project. You can refer to that video. So when I say build in Gradle, it will compile the Java classes. There's also Scala because there is Scala dependency here, but let's leave that. So it's compiled, it's built now. So if you go to this particular module, Idea Projects Code with me, if you open this, you will find a build folder here marked orange. So all the orange marked folders are basically generated files in your IntelliJ. Generated files mean they get generated every time you run this build newly. So you open this, you see classes folder. So open this, open Java. So these are called as class files. This is javacar.java, which is a Java file. Source code is what you call this. So open this. This is a class file or bytecode of the corresponding source code. So this is your source Java file. This is your bytecode of it. So what basically happens behind the scenes is when I hit build, okay, your Java compiler basically will compile the code Java C space. In this example, javacar.java. This is the command that's executed, and this will give a result as javacar.class, which is exactly what you see here. So once you have this file with you, what happens next is your Java runtime environment provides the interpreter as well for you to execute this. Let's say Java space javacar. That's it. And this will run your code for you. This will basically perform the interpretation. That is, execute this bytecode. This is called as the bytecode, right? So it will execute the bytecode. So basically, Java's code, how it differs from C++ or other languages is compilation plus interpretation. All your C, C++, and other languages are relatively faster than Java. The reason is they have only the compilation part, and directly the compiled code is executed. Whereas there is a compilation happening in Java, which produces an intermediary bytecode, which is .class file, which is then interpreted by the interpreter in Java. All this is happening within the JRE or Java runtime environment. JVM is helping you execute these. Okay. So once you have this picture in mind, you can say that one very important aspect of Java, which differentiated it from other languages, is Bora, which is write once, read anywhere. What I mean by this is the compilers, right? So let's say I compile a Java. So these class files that you see here, right? I can take this build, I can put it in a zip file, and I can send it to you. My operating system is Linux, and I have this byte file generated here, bytecode file. I can just take this, zip it, and I'll send it to you. If you have a Windows system or a Mac machine, you can download this file. If you have JRE is available as a standalone package. You can just download the JRE alone instead of JDK. So if you just download the JRE, you can directly in your system execute this class file. You can simply run your Java code that I have compiled in my system. That is the reason why it is called as write once. So you can write it in my system or your system or anyone's system. But once I've converted that to the bytecode, this bytecode can be executed anywhere in this world in any system which has a JRE, Java runtime environment. So that's the beauty of Java. The compiler of Java is platform dependent, but the interpreter is platform independent. So basically any JRE in any system will be able to interpret the bytecode produced from any of the operating system JDKs. Like for example, one that is produced from this Linux machine, the bytecode can be executed out in a Windows machine. This gave a significant boost to Java as a language because this is a very niche feature at that point of time when Java came out. And this is one of the standalone features of Java. Of course, because there is a compilation and interpretation happening separately, it was slower than C or C++, but convenience always wins over anything, right? So this was a quite convenient way. So that's pretty much it with what Java is all about. And I think that's pretty much it for this video as well. I think this video might have extended slightly more than 10 minutes. If not, fine. If it is, then please forgive me. I'll try to time box the videos again. But since this is an intro video, I just wanted to be thorough so that you have the concepts clear. I'll see you guys in the next video. We will be talking more about Java and the ways of programming with OOP and Java. Until then, take care. Bye-bye.